Okay, let's talk about some of the invisible rules that keep our world moving. We're going to start with a question that seems pretty simple on the surface, but it's not. Just take a look at this. It looks straightforward enough, right? But what you're seeing are stacks of timber weighing thousands and thousands of tons that get shipped across the world's most turbulent oceans right out on the open decks of ships. This is a massive logistical puzzle that gets solved every single day. So, how do they pull it off? Seriously, what is preventing this entire mountain of wood from shifting, breaking loose, and just crashing into the water? Well, the answer is a really fascinating mix of some clever engineering, a little bit of physics, and one crucial international rulebook. Okay, first things first, let's really get a grip on the sheer scale of the challenge here and why getting this wrong can be absolutely catastrophic. We are not just talking about losing some lumber. The forces at play are just immense. I mean, a single rogue wave can slam into that cargo with unbelievable pressure. If the stack shifts even a little, it can throw off the ship's balance and capsize the entire vessel. And if the timber falls overboard, well, you've just created a massive, semi-submerged hazard drifting right in the middle of the world's busiest shipping lanes. So, to combat this very real danger, the world's maritime authorities knew they couldn't just leave things to chance. They all came together to create a single, comprehensive guide for everyone to follow. It's called the Timber Deck Cargo Code, or the TDC code for short. And let me tell you, this is not just some boring piece of bureaucracy. Nope, it's basically a life-saving blueprint, developed by the International Maritime Organization. It takes decades of hard-won experience and boils it down into a set of precise instructions. So here's the crucial point to understand. Safety starts way, way before anyone even thinks about tying a rope. It all begins with how you build the stack in the first place. You have to think of it like building a house that has to survive a nonstop earthquake while floating on water. So before even one log gets loaded, the crew goes through this super detailed checklist. They're securing hatches, protecting vents, and even scraping off any ice, which, as we're about to see, is a huge enemy. They also have to manage the ship's ballast tanks to reduce something called the free surface effect. That's just a fancy term for the dangerous sloshing of water inside a half-full tank, which can seriously mess with a ship's stability. And this right here, this quote from the code, is the whole game. This is the guiding philosophy behind everything. The goal isn't just to stack the wood neatly, it's to make that entire massive pile of timber act like one single solid block. Every other rule exists to make this happen. So why all this fuss about a solid block? Well, it's because any empty space inside that stack, what the code calls a void, is a critical weak point. In rough seas, the cargo can shift and squeeze into that void. When that happens, the ropes and chains holding it all down suddenly go slack. And slack lashings, well, that's how disasters begin. So how do you fight these voids? Well, engineers use these really simple but totally effective structures, like these wooden H-frames. You just wedge them into any gaps to fill the space. It helps lock all the cargo together, turning that loose pile into the solid block that you're aiming for. All right, so we've built our solid block of wood. Now let's talk about the next step. How do you tie this enormous thing down to fight the relentless forces of the ocean? Now, crews have a couple of main tools in their toolbox for this job. They'll usually choose between these high-strength chains for maximum security or these more flexible web lashings, which are a lot easier to handle. The choice really depends on the specific type of timber and the ship they're working on. The whole lashing process is actually multi-layered. First up, crews often use what are called hog lashings. Now, these are cool because they actually run through the cargo stack, pulling the vertical supports inward. It's like the cargo is squeezing itself together from the inside, making it even more solid before you even start tying it down from the top. Next, you've got the top-over lashings, and these are the real heavy lifters. Think of them like a giant seatbelt that goes over the entire stack. They get cinched down with immense force, holding the whole pile firmly against the deck of the ship. And then, for certain types of cargo, especially things like round logs, you might see this incredibly complex-looking setup. It's called a wiggle lashing. It's basically one continuous wire that zigzags back and forth across the top, creating this perfect web of security that spreads the tension evenly across the entire surface. Pretty smart. And the code gets ridiculously specific because every single tiny detail matters. Just look at this, the rules for how to attach a simple wire rope clip. The saddle part has to go on the live end of the rope. That's the part that takes the load. If you put it on backwards, you can weaken the rope's strength in a big way. It's exactly this kind of attention to detail that makes the difference between safety and failure. But, the job isn't done just because the ship has left port. Nope. The journey itself presents a whole new set of challenges that the code has to prepare for. For instance, you can't just stack the timber to the sky. The code is super precise about this, making sure the stack isn't so high that it blocks the captain's view from the bridge. I mean, they have to be able to see the sea ahead to navigate safely. Seems obvious, right? But it's so important it had to be written into the rules. And weather, oh man, weather is a huge factor. Just look at this table. It shows you exactly how dangerous ice is. The friction, basically the grip, between sawn wood and a steel deck drops by nearly 90% when ice forms. 90%! That's why getting rid of ice before you even start loading is so critical, and why crews have to be extra careful on voyages in cold weather. And, in the end, after all the technical rules and hundreds of pages of specifications, the code itself admits a simple, powerful truth. These rules are a tool, but the most important safety system on any ship is an alert, experienced crew that knows when to slow down or change course when the weather gets bad. Look, the Timber Code is just one example out of thousands of these kinds of super specific, globally agreed upon protocols that make our modern world actually work. They are the invisible architecture of global logistics, and each one is a story of a problem found and a solution engineered, all to keep things moving safely. So next time you see one of those giant cargo ships on the horizon, you'll know a little bit more about the invisible engineering that's holding it all together.